welcome to my derivatives part 2. And I have not seen my derivatives part 1, go to the playlist and see it, because it includes how can you find the derivative of function using the direct method. And in this part 2, we'll be studying how can you find the derivative of function using the first principle. Okay, so I'm writing the method name. See, first we studied the direct method. Direct method. Then we studied, and then we are going to study the first principle method. Okay, now what is this first principle? First, let's see that. It is nothing but it is a formula, and I am writing that formula here. Limit h tends to 0, f(x) plus h minus f(x) by h. Okay. Now this arrow means that the value of s is very close to 0. It might be 0.001, it might be 0.01, it might be 0.0000001. If they are very near to 0, this arrow means that the value of h is very near to 0. But we take h to be 0 only, because it is approximately 0. Okay. But what does this formula mean for now? Okay. Let's say we are told to find the derivative of x square. Okay, so how can we do it? By the first principle. Okay, let's see it. First we need to note down that what is our fx. So your fx is nothing but it is x square. Okay, now we know that our h is 0, we know that our fx is x square. But now what is our fx plus h? See, whenever in this equation, wherever there is a x, you have to replace it with x plus h. I repeat, wherever in this equation there is a x, you have to replace it by x plus h. Here it is x, so we replace it by x plus h, the whole square as it is. Now we can substitute, because now we know the values. So let's write x plus h whole square minus x square by h. Now I'm not writing limits in each step, but if you are giving and test or an exam, you have to, it's compulsory for you to write limit in every step. But I'm now just writing in the formula, and in the last step I will write the limit. Okay, that can be done in both the ways, that you can do it a square minus b square, you can do it a plus b whole square. Okay, both methods are correct because their answer would come right from both methods. I am doing it a plus b whole square, or it will be x square plus h square plus 2xh minus x square by h. Now we can see that these two will get cancelled. Okay. Now in between I must say that if we now put the value of h to be 0, okay, because the update limit is h to be 0, means h tends to 0, okay, and we take h to be 0 only. So what if we put the value of h 0? Let's see. 0 plus it would be also 0, and 0 plus 0 is 0 by 0. Means our answer is coming 0 by 0, which is invalid. So let's see if we can make any change, if you can make any further changes in this equation to avoid the answer of 0 by 0. And I can see that I can take out h common from the numerator. So let me take out h common, because it would at least simplify equation a bit. Okay, 2x in bracket h. Now I can also clearly see that h and h are getting cancelled, and it is very good thing for me, because if in the denominator an h does not exist, means there is no chance that n 0 would also exist in the denominator. See, we know that h would be 0. So if we only cut the h, where could the 0 come from the denominator, right? So please make a main practice to cancel h. How we can cancel h? Try to cancel first h from the denominator. Okay, or else it would lead to a big problem. Now there is 1 in the denominator, and so the leftover equation is h square plus 2x by 1. Now we can put the value of h to be 0, and that would be 0 square, that is 0 only, and 0 plus 2x is 2x, right? So the derivative of x square is 2x, even you can check by the direct method. So friends, now let's take a second example on the screen. Okay, let's say now we have to find the derivative of a little complex number. Let it be x inverse. Okay, we have to find the derivative of x inverse. Okay, so how can we do that? First, let's write the formula of first principle. Limit h tends to 0, f x plus h minus f x by h. Okay, now we know that what is our fx, right? So let's put in what is our fx. Fx is equal to x inverse. We could also write x inverse as 1 by x, no problem. Okay, now we have to find what is f x plus h. Okay, now let's see what would be x plus f x plus h. Wherever in the equation there is a x, you have to substitute x plus h. Okay, we started it. So let's substitute it x plus h raised to minus 1, which would be 1 by x plus h, right? Okay, so now let's put in our values. This video is a little longer, I know, but I'm just clearing the concept because it is a pretty complex topic. Now it is 1 by x plus h plus x inverse, which is, it is minus sign, minus x inverse, which is 1 by x by h. I am still not writing the limits. I will write in the last step. Okay, now I can see that we can do no more simplification. So let's take out the LCM. Okay, so x minus, it would be x plus h in the bracket because there is a minus sign, by it would be x square plus hx. Okay, now and the whole equation divided by x. Okay, now let's open this bracket. X minus x by x square plus hx multiplied 1 by x, this h in denominator. Okay, now I can clearly see that this x and this x will get cut, and I can also clearly see that we can cut this h and this has to be minus 1. Okay, so what the equation is left, let's write it here. It would be minus 1, then x square plus hx. Can I simplify it even further? Yeah, but if we leave the equation here only, it won't matter. Let's see if we can simplify it further. It would be minus 1 and we can take out x common from this, the denominator. It would be x plus h. And now we would just put h to be 0. Okay, and what it would be? Minus 1 x square plus 0, which would be minus 1 x square. Even you can check by the arithmetic method, the derivative of x inverse will be minus 1 x by x square only. So friends, if you really like my video and if it really helped you, please hit the like button and don't forget to subscribe my channel.